Hello everyone, my name is Ashwini. Welcome to my channel. Today we will discuss a topic from theory of computation, that is obtaining a regular expression. Today we will discuss some of the rules for obtaining a regular expression. Later we will solve some of the problems. Let's look at the rules for obtaining a regular expression. Here are some rules for obtaining a regular expression. For example, epsilon, which contains no string at all, nothing at all, and the epsilon, which is an empty string. If you multiply a null by a epsilon, we get a null. Epsilon plus epsilon, which is equivalent to epsilon. Here epsilon dominates, whereas 1 plus 1, which is equal to 1, and 0 plus 0, which is equal to 0, and 0 plus 1, which is equal to 1. These are some union rules. And we are also have a factoring patterns, that is 0 plus 0, 1, which is equal to 0 bracket of epsilon plus 1. Then here we see some regular expression operators, which are concatenation, union, chain star, and a positive closure. Here concatenation means alpha beta combines two expressions sequentially, whereas union accepts either of expression, whereas chain star repeats 0 or more times, whereas positive closure, that is alpha to the power plus, repeats 1 or more times. The major difference between chain star or a positive closure is, whereas chain star contains 0 or more times, whereas positive closure, there must be at least one alpha should be present. Here are some essential rules for obtaining a regular expression, that is null operation, identity operations, union properties, and a factor. In null operation, if you multiply a null by epsilon, we get a null. And if you multiply 0 by epsilon, which is equivalent to 0 only, if you multiply 0 by null, we also get a 0 only. Identity with the epsilon, if we add null with the epsilon, we get a epsilon. Here are some union properties and factoring properties, which are discussed in a previous slide. Here we go for a language operations, which is concatenation and a union. If the language of alpha beta, which can be written as language of alpha concatenated with language of beta, and for union, the language of alpha union beta can be written as language of alpha union language of beta. Here are some special symbols in a regular expression, which is null set and a epsilon. You might get confusion between null set and a epsilon. The null set, the language of null set contains no string at all, whereas epsilon language, this language of epsilon contains only the empty string. Let's look at some of the problems. Here is the first problem. Obtain the regular expression for the language to accept the strings of zeros and ones with at most one pair of consecutive zeros. Here we have valid strings. Here we have at most one pair of consecutive zeros. Here we also have at most one pair of consecutive zeros followed by any number of zeros or a 1. Here we have three consecutive zeros, which is a not valid case. Here we look at the solution. We can write a regular expression for this problem is as follows. We can write 1 plus 0, 1 to the power whole star. We can have a 1 or either 0, 1 followed by 0 or more times, followed by one pair of consecutive zeros, followed by n number of 1s. If we take a 0 here, we will get a 3 consecutive zeros, which is not valid for our question. This allows any combination of 1 or isolated zeros and a 1, then exactly 0, 0 followed by only 1s. Here we look at a second question. Here we want to have a substring pattern AABB. Here we have a problem statement that accept any string containing the substring AABB anywhere within it. Here we have a solution. We can have any number of A's and B's followed by the string AABB, then followed by any number of A's or B's. Here, first A plus B whole to the power star we can have any number of A's and a B's. We have any prefix. Then in the middle, we can have a required substring, that is ABB. At the last, we have the suffix A plus B to the power A plus B whole star, which gives a combination of n number of A's and B. There are some valid examples for this problem statement. ABB, any number of A's or B followed by AABB followed by Y, and AABB A. Then this is our third problem statement. Here we want to obtain a regular expression for a string containing A's and B's with alternating characters. With the alternating characters A's and B's. Here we can solve this problem in two patterns, pattern 1 and a pattern 2. Here we can write this problem as, here a string can start with A also, B also. If string have a BA pattern, here we have a solution. String starts with optional A followed by BA pattern and ends with optional B. In pattern 2, string starts with optional B followed by AB pairs and ends with optional A. These expressions accept the strings where A's and B's are strictly alternate, such as AB AB or BABA. Thank you.